my hand at your talk and tell you should be more careful.
But so there is a way, in theory, so the global alignment thing, if I understand it, just to make sure, is you do run LDA multiple times, and there's a way to look at the distribution of words in each run for whatever topic and compare it to the distribution of words most similar in a separate run.
Exactly. Well, yes, exactly.
Okay.
That's exactly what it is, sure.
But people don't normally do that.
No, they don't.
The run is allowed for what reason?
Well, first of all, no one knew this was a problem until last year, or at least basically no one did. I mean, so I feel like topic models are everywhere and that, it's the most obvious thing in the world, but, that means that there's like 20 or 50 people who care about them. And, well, yeah, regardless. And it's also not easy. I will show you a method that these people have developed, Robert, Stewart, and Tingley, to make it a little bit easier. So.
Does that mean, if nothing else, that just seems like a really good way to validate not even the topics that you're assigning subjectively, but just that you have some kind of consistency, right?
Yeah, exactly.
Weird local maximum. Huh.
And so this is the example from that paper that shows that it does tend to matter. So they have these different topics they've identified, and it seems that some topics are more stable than others. They've done the same thing that I described, where they ran LDA from lots of different initializations and found the results. And so this Cheney topic tends to not be very stable. So this is that pairwise similarity measure. So how many words out of the top 10 are being shared between the documents. So it seems like for technical things like the Supreme Court and climate, these words are very obvious and they're always going to co-occur. But for things like, so this is a talk about Cheney, and there was some question about whether or not this was a topic that was about Bush or not. And depending on where you started, you tended to get more Bush words or more words that were specific to Cheney and the war stuff. So, yeah.
Is it wrong to therefore think, well, Jen, just add one more to K, divide that topic, and let her rip?
Right, exactly. So the choice of K is also sort of determined by what we are interested in. Mm-hmm. If we think that maybe it makes more sense to have a topic where those two things are combined, we shouldn't. And if we think it does make sense to divide them up, we should. Right.
But the point is that if you have like this weird thing that it's sometimes Bush, sometimes Cheney, and then you add another, you increase K by 1, it could also do something completely different.
It can divide another thing.
Right.
Divide another thing instead of
exactly. Yeah.
Yeah,
so.
I get that.
All right. All right, good. That's right. So let's go back to our little run here. So it's finished. Very good. So now we're going to actually extract, this is the distribution of topics over documents. It's called gamma here.
So gamma is the distribution of topics. Okay.
Right. That's what we're interested in. And now we are going to look at the distribution of words over topics, which is beta. And we're going to do a little visualization. So this is a method I did to look at the topics over time. First, we have to make sure we're in the right, so that the days are columns, so we can plot them. See what it looks like here. Oh, that's right. I just want to make sure that we have the right column, so it's not informative. And so what I'm going to look at now is for each document, which, again, these documents are for regime elites per day, what they tweet about. I'm going to plot the number 1 topic and the number 2 topic for each day by coalition.
And you're totally agnostic about what these topics are.
Oh, yeah, for sure. We're going to see that we can interpret them a little bit. But yeah, so my task in the paper is not to do that, not to interpret it. I have to define a function to find the second max of a list. So if you were curious about finding the second max of a list, that's the way to do it. It's non-trivial.
Really?
Yeah, it was just a pain. So we're going to actually turn that into dates. I'm going to define some vectors and some data frames. Oh no. Did I not do that? Oh, what?
162 dates and 320.
So right, no, it's just because that the first half of them are the government, the second half are regime. Oh no. Why would you do that? Maybe I pressed this too many times. Let's pray that works. Nice. Okay. Right. I just transposed it one too many times. I'm sorry about that. So let's actually plot this. So we'll use ggplot here. If you're interested in how to get it to look like this, the code is definitely all on the GitHub. Yeah. So what we have, we've plotted the two topics over time. The filled in circle is number one topic, and the open circle is the number two topic. We see x-axis is dates, and this is for the regime. We're going to look at the opposition in a second. We see remarkable stability about the number one topic. It's always the same. And we also see...
like the number one is just that line?
Yeah, that line.
Yeah.
I thought it was some, okay.
Right. And so the y-axis here is just the topic number. So
Hold it, but what does that mean? You just said you're plotting the first and second topics.
the first and second highest probability topics. So the topics each have a number. These numbers are completely random, completely uninformative. So the y-axis is completely uninformative.
So this second topic means the second topic that occurs in each document with the second highest probability.
With the second highest probability, exactly.
Oh, I see.
Yes.
The y-axis is just identifying what.
Right.
what
Which
that is.
which topic that is.
Okay.
Yeah.
That's arbitrary here.
Basically, it says that the first topic stays, it's always the most typical topic is always the same, and then the second one
Yes.
is sometimes the same, but sometimes.
That's exactly right. And this is indicative, I think, of the fact that we have not done the best job of stop words. So we see this if there's just lots of words that show up every single time in every topic. And in this case, we're sort of agnostic as to whether or not we're interested in those words. We actually have to go in and look at the data. But this is the sort of problem you run into in the real world when you're running these kind of algorithms. So you should be...
The stop words cause the first one to be the same or the second one not being the same?
The first one to be the same. If there were no stop words, I would expect more variation in the first topic. At the same time...
But because the first topic has a bunch of like or...
Yes, for example, or other words like that. Probably we've removed the L, the Spanish version of the, and things like that with the stop word list. We're not sure exactly what words are causing this. We're going to look at that a little bit. So for the opposition, this is how it looks.
It's going to be an error.
No, it doesn't matter. Not an important error. So, yeah.
Except now you also have a more consistent second topic down there on number 10.
Yes, exactly. And in general, there's less variation going on for the opposition. Right. So before we get to STM, we're going to look at a couple of other applications where we relax some of the assumptions of LDA. So the first is relaxing this assumption that the topics are uncorrelated. We can say that there might be a correlation between the topics. So this was soon after LDA came out. Bly and a guy called Lafferty came up with this correlated topic model. So it does make sense that if we know that a topic, like a document, is somewhat about a certain topic, there are topics we would expect to also be more likely to occur in that document. And so the original assumption in LDA that they are uncorrelated doesn't make any sense. So if we actually allow them to be correlated and we allow ourselves to learn about it, we can have an algorithm that's more efficient. So the problem is, though, that if we have some method, we allow them to be correlated by some distribution here, logistic normal. The logistic normal is not conjugate to the multivariate, and so they had to come up with some additional method using variational inference to solve this problem. That's why it took so long.